Okay, Hangout on Air is live, and hello everyone. And I think this is actually our first VJug session since VJug 24. I think. Oh no, sorry, we had one earlier, but that was like a kind of hack session on the Saturday. So this is actually our first VJug session since VJug 24. And I believe, Arun, you were also our last VJug session before VJug 24. How are you doing, Arun?
I'm doing very well. Now, yeah, excited to almost ending the year now.
Yeah, oh, it is. It's gone quick this year, hasn't it? And I think actually most people will after everything that's happened this year, we're looking forward to 2017, right?
Yeah.
Hopefully,
yeah.
Hopefully the world's luck will be better then. But anyway, enough about that. Yeah, today we're talking about Kubernetes for Java developers, and let me quickly share my screen actually so I can show you some slides. Which one is it showing? It's sharing. Oh, that's interesting. Yes. Okay. Can you see my slides now?
Yes, I can.
Awesome. And it's the big full screen one, yeah?
No, it's not the full screen one. I can see the keynote by itself. So you have to click on the play, then it'll see the full screen.
Oh, okay. In that case, it's just picking the wrong. Okay, we'll do it in this mode. That's absolutely fine. We have up now is Kubernetes for Java developers with Mr. Arun Gupta. And if you haven't followed Arun on Twitter, please do at Arun Gupta. Arun has many thousands of followers, and he has a whole bunch of really amazing stuff to tweet. So make sure you follow Arun. The VJug is sponsored by Zero Turnaround, creators of revolutionary developer tools. So do check out some of the free trials that you can use for JRebel and XRebel, tools that allow you to reload your code changes instantly, and also a profiling tool that allows you to catch performance problems during development. Also, one of their latest releases, this is actually in the early beta phase, is the XRebel Hub, which is the ability to catch performance regressions in your testing, all the way from CI up to your kind of staging time. So, as when you run your automated test suites, you can use XRebel Hub to catch regressions within your builds. So do check that out, xrebel-hub.com. If you're viewing on the on virtualjug.com, you'll be able to see IRC right next to the YouTube embedded YouTube widget. So you can click on that and you can talk to each other and also ask questions in there, and I'll catch them and I'll put them to Arun. If you're not on virtualjug.com, you can log into IRC using channel #virtualjug, and that's a free node chat. Please do share the group and session. We're over 10,000 people now, so it's really amazing how we've come this far, and let's go further. So please do share that session. And of course, if you have any feedback, as usual, you can tweet me or the Virtual Jug and let me know what you think about the setup, or about the talk, or about talks you wanna see on the VJug. So do give us feedback. So without further ado, Arun, I'm going to pass over to you, and we can learn about Kubernetes for developers.
All right, let's find it out. So I'm going to go ahead and share my screen here. And I'm going to share full screen. And here we go, live. And you can see my screen?
That looks good.
Fantastic. Okay, excellent. Thank you once again. Really proud, really honored to be here on Virtual Jug. This effort was started like less than 3 years ago or so, and it's mind-blowing how the community has grown. So there was a definite demand for this. It's probably one of the fastest growing meetups that I have seen. So all kudos to Simon and Zero Turnaround for running the show here up until now. Today, the topic of the talk is going to be Kubernetes for Java developers. My name is Arun Gupta. As Simon said, like anybody and everybody, I have a Twitter handle as well. I'm a Docker captain. That means I'm recognized by the company Docker. That means I know a few things about Docker. And I'm also a Java champion. That means I'm recognized by Oracle that I know a few things about Java. So that kind of makes me a little bit more credible to talk about Kubernetes for Java developers. One of my passion is about DevOps for kids, where I want to bring technology to each and every kid in the world. And so as part of that, I founded DevOps for Kids USA. We have chapters all across the world, which was originally started in Belgium. But now there are chapters all over the world: Belgium, Holland, Netherlands, UK, France, Morocco, Turkey, everywhere. And of course, I run the local chapter. And then on the right side, you see is a bunch of books that I've authored so far. And the latest one that is getting added to the arsenal is Kubernetes for Java developers. So a detailed book, well, a mini book is coming from O'Reilly. So stay tuned on that one. So what is Kubernetes? Well, Kubernetes is an open source orchestration system for containers. If you have been living under the rock, then you probably don't know what Docker is or containers are, what advantages they serve. So I would say go ahead, read something. But assuming that you know what a basic Docker container provides, your application typically consists of multiple Docker containers, and those containers need to be scheduled. Those containers need to be orchestrated, which host to run on, what memory requirements, what CPU requirements. So in order to do that, you need an orchestration system. And so Docker has an inbuilt orchestration system called as Docker Swarm Mode, Docker Engine with Swarm Mode. There is Mesos or DCOS by the company Mesosphere and Apache Mesos. And Kubernetes is an open source orchestration system. I mean, by the way, all the two that I mentioned are already open source, but this is an alternative orchestration system by Google. Kubernetes claims that they are container agnostic. So Docker, RKT, or OCI compliant implementation, anything that you care about could be plugged in there. But in all my speaking experiences, writing experiences, blogging experiences around the world, I've never seen anybody using RKT with Kubernetes. So 99.9999%, it's always been Docker. RKT is mostly for experimental purposes I've seen. What does it give you? Well, it allows you to provide the declarative primitives for the desired state. You say, hey, here is my application. My application needs to have a certain number of replicas running, certain number of services running, and the services need to be communicating this way. Kubernetes maintains that, independent of a container format, Docker, RKT, whatever it is. It is self-healing. That means if a container goes down, it automatically brings the container up. So it's auto-restarting as well. The containers can be scheduled across multiple hosts. So you have multiple containers across multiple hosts, typical application, typical deployment for high availability. And you also have the capability to replicate your services. You have a cookie cutter recipe that can be done to, say, spin up 5 instances of Wildfly, spin up 4 instances of Couchbase. They'll do all of that. Let's get into Kubernetes concepts. So we understand that on a node, which is a physical machine or a VM, doesn't matter really, but on that node, there is a Docker host running. Docker host does all the provisioning, running, downloading the image, running the container, all of that stuff. Now, on top of that, the basic unit that Kubernetes provides is called as a pod. Pod is nothing but a collocated group of containers that share an IP namespace storage volume. Typically, the typical use case I've seen is one pod with one container, but in certain cases, you will see multiple containers can be run within the pod. And we'll talk about those use cases a little bit later, but essentially, the containers within the pod can talk to each other using localhost as if they have the same IP namespace and storage volume. Now, one pod is good, but typically you want to run a replication of that, a replica of that. So run 6 instances of Wildfly, 4 instances of Couchbase. That's the concept of a replica set. A replica set manages the life cycle of pod, and then if you say 6 replicas, and that's what I mean by desired state, and if that instance goes down, if that pod goes down, Kubernetes cluster automatically brings it back up again. Each pod has an ephemeral IP address, so you can't really rely upon it. This is very relevant, particularly in a database case, because if you're taking a Java application, talking to a database, you need a well-defined name, a host port name. And that's fundamentally missing if you're using port or a pod, because pod ephemeral IP, could be scheduled on a different host. So you can't really rely upon that. And that's where service comes in. Service is a single stable name for a set of pods. And it also acts as a load balancer. So it can just do round robin across those different pods that are within the service. How do these really work with, how do services and pods really work with each other? It's a very loosely coupled architecture where each pod is assigned certain labels, and those labels are essentially stored in a registry, and services are looking for those labels. So it's completely self-organizing in that sense. Talk a little bit more. In Kubernetes concepts, you have the concept of a machine or a node. Well, node is a machine or a VM in the cluster, as we talked about it. There are two types of nodes. There is one master, which is basically the central control plane, which provides a complete holistic view of the cluster, which is how you control the cluster, etc. Within the master, you have a HCD, which is what we talked about earlier, where the labels are stored, which is a distributed watchable registry. There is a scheduler, which is responsible for scheduling the pods across multiple hosts, which pod is going to schedule at which host. And there is a controller manager, which is responsible for controllers like Replica Set or Replication Controller, which defines, which kind of monitors those state of the replica set. And then there is, of course, a worker. Worker is where the containers are actually run. Now, on the worker, or the pods are really run, but on the worker, what you have is a kubelet. This is sort of a node agent, and is monitored by your local operating system services, like systemd on CentOS or Monitor on Debian. And then there are proxy services, which basically we talked about service. Service acts as a load balancer and can act as a proxy as well. So those are sort of your key components in terms of Kubernetes. Now, using that, if I were to actually create a Kubernetes architecture, I have a master, scheduler, controller manager, etcd. There's an API server, which is essentially where my CLI or my applications interact with. There is a kubectl. Kubectl is a CLI tool that comes along with Kubernetes binary. That kubectl binary directly talks to API server, and it says, create a resource. The resource could be a pod, could be a replica set, could be a service, whatever. All the different kind of resources we talked about. And there are a lot more, which we haven't gotten into yet. Then, of course, there are a bunch of workers. So in this case, we're just showing two workers. Each worker is very exactly alike, kubelet proxy. Now, the underlying operating system is recommended to be homogeneous. The hardware could be different, like the memory capacity, etc., could be different, for example. Now, from kubectl, you make a request to master. I'm showing the internal components, but essentially you make a request to master, and the master says, oh, API server is the one that's going to receive this request. Then the API server, after it has talked to the scheduler, figures out where the pod needs to be scheduled. Then it talks to the right kubelet, and kubelet does the job of actually running the pod on that particular host. So it schedules the pod. If the request comes to create a service, or if the request comes to access a service, then it goes through proxy. On the right side, what you see is your client application. The client talks to a load balancer, then load balancer figures out which proxy to talk to on which host, and then accordingly, the request is served. So the two diamonds that you see, sideways diamonds that you see, kubectl is a CLI, where you create the resources. On the right side is your client application. And this, the square that you see, the kind of a different shaped square, is a Kubernetes cluster. This is sort of the key components of the Kubernetes cluster. Now, if you download Kubernetes 1.4.5, which was released a few weeks ago, and I haven't updated my release recently, but in that there is a single master, and that's a fundamental problem, because single master means single point of failure. And so this analogy goes really well. This is a GRU and a bunch of minions. What we call as node used to be called as minions. As the terminology has changed or evolved rather. So that's sort of the analogy here. But there are other ways by which you can run multiple masters, and we'll talk about that in a second. So kubectl, as we said, is my CLI, which is how I create all the resources. Any application that I'm running is basically creating a bunch of resources. It controls the Kubernetes cluster manager. I can CRUD Kubernetes resources. Any application that you do is all about CRUDing those resources. You can say create a resource, get a resource, describe a resource, delete a resource, and I'll show you examples on how that can be easily done. The way you create, you essentially give it a configuration file, and file has either YAML or JSON description of what the resource is going to do. And we'll go through several of those resources, how they're going to take care of it. Once you have created a resource, you may want to see, okay, I created a pod. I want to take a look at the pod. Then you say kubectl get pod. Or if you're configured to the cluster, then you can say kubectl get me the nodes. Show me what all nodes are existing in the cluster. Okay. You may want to say kubectl, I want to scale the number of replicas of a replication controller to 3. And of course, you've got to give it the name of the replication controller as well. So that's sort of how your typical kubectl usage would look like. Now, what is the easiest way to fire up development, to do development in Kubernetes? But earlier, it used to be Vagrant based, if you don't want to go into cloud or anything like that. But Vagrant was quite memory sucker, so that wouldn't work. Now, Minikube is, again, a project by Kubernetes. So go to github.com/kubernetes/minikube. You can download Minikube from there, but it runs a single node cluster in a VM. Very well suited for local development. I have switched to Minikube for past few weeks now, and I pretty much do all my local development in this. It's a CLI. All it needs, it's a single CLI, and all it needs is kubectl, because this is how you manage the cluster. So if you're looking for more instructions, the bottom of the slide actually has a URL which shows you exactly how you can fire up a Minikube cluster, how you can configure it, how you can use kubectl to create resources. The commands are pretty identical, actually exactly identical between Minikube and a full-blown Kubernetes cluster, which could be fired up on Amazon and a bunch of other clouds. Well, so this is what it is. So now you can download Kubernetes release from github.com/kubernetes/Kubernetes releases. And that release you can run on a variety of clouds. My typical preferred cloud provider is AWS. That's where I end up running. It's super simple. Google Compute Engine, I've tried running it as well, and it is very identical once you have your Cloud SDK, Google Cloud SDK configured well. So you can do it both ways. But then there are other providers as well where you can fire up Kubernetes. And on my blog, there is also instructions on how to get it running on Windows Azure as well. Now, the releases, well, Minikube is a single master. The releases from GitHub Kubernetes is a single master. If you are really interested in a multi-master Kubernetes, then COPS. COPS is, again, another project by Kubernetes. My blog link at the bottom talks about how do you fire up a multi-master Kubernetes cluster. You can do this on any cloud that you care about, but COPS is basically what it does. Well, COPS stands for, first of all, Kubernetes Ops. So kubectl do CRUDing of resources in a Kubernetes cluster. Think of COPS as a CRUDing of cluster on different cloud providers. So whatever kubectl does for Kubernetes resources, COPS does that for Kubernetes clusters. So again, the instructions on the bottom of the screen are pointed to my blog and should guide you more. All right, let's fire up our Kubernetes cluster. I'm not going to fire it up. It takes a while because essentially you have the release, then you start a cluster, you run some scripts, it uploads your Kubernetes distribution, which is about 1 gigabyte big, to S3, and then it provisions those machines. So it takes about 20 minutes or so, because by default it fires up 4 node, 1 master. So it takes about that. There are plenty of instructions available for that. We're not going to get into that. Now, once you have fired up your Kubernetes cluster, the first thing you want to do is start a pod. Now, I just want to play with it. So this is how your pod configuration file looks like. So let's walk through it a little bit. Line number 1 says API version. So resource configuration file can have different versions. V1 is sort of still referring to Kubernetes version 1. There are a bunch of different API versions, extensions and alpha. And if you search for Kubernetes API versions, it will tell you about how those API versions have evolved. Alpha means they can break backwards compatibility. Beta means it's not final, but it's ready for testing, and you can do more aggressive deployment with this. V1 is the final version of the API. On line 2, it talks about it's a pod. There are different kinds of resources. So that kind of resource is specified here. Line 3 to 6 says the metadata that can be associated with a Kubernetes resource. Line 4 basically says name. And line 5 and 6 says, what are the labels associated with this resource? In this particular case, I'm giving it a label. Remember, we talked about service. A service could be watching for this label. So that's sort of how the labels are assigned. Line 7 says, okay, this is the specification of the pod, and in the pod, I have only one container. Line number 9 says, what is the container name? Line number 10 says, what is the container image? 11 and 12 says, what are the container ports that are being exposed? So very simple, very clean, easy way to read your pod configuration file, okay? Let's take a look at replication controller. As we talked about it, replication controller runs a specified number of pod replicas. So you say run 4 instances of a pod, it'll make sure or the Kubernetes master or Kubernetes cluster will make sure 4 instances of a pod are running, okay? Essentially, pod templates in that sense becomes cookie cutters. It applies that cookie cutter recipe to all the pods. Those cookie cutter recipes can be manipulated using environment variables. So that's entirely possible. And if a pod dies, it can bring up on a different host. So it's completely independent. You don't have much control on that, actually. A replication controller can be manually scaled, where you can say, okay, scale from 3 to 5, or you can set up like horizontal pod autoscaling, which we'll talk about it a little bit later as well. To the replication controller, you can do rolling updates as well. We'll talk about that concept a little bit later. And generally, you would not start up a pod by itself. You will wrap it up in a replication controller so that you are guaranteed to have that pod up and running. Okay, and then it's only appropriate for pods where the restart policy is set to always. Because if you set the restart policy to never, that would be an invalid pod for replication controller, because replication controller will try to start the pod if the pod dies for some reason. Here is my pod configuration file, essentially. Line 1, 2, 3, 4, 5 are very similar. Line 6 is where I'm saying, okay, I want 2 replicas of the cookie cutter recipe. Line 7 and 8 says, okay, I'm going to look at the pods that are going to be part of my replication controller are using this particular label that is specified on line 8. And if you look at line 9 is where my pod cookie cutter recipe is defined. And line 12 specifically is where the label is. So line 8 and 12 are exactly matching, although line 7 and 8 are optional. So if I don't specify it, it by default takes that and put that into the selector class. And line 13 onwards is basically my pod specification. So very simple, okay? It just extends pod specification file. So now I have a master, and then on the master I said, okay, create a replication controller. Replication controller has 2 replicas, so it fires up those 2 pods. How does the reconciliation happen? So now let's say I have a worker 1, worker 2. Now I have a worker 1, worker 2 on the right side as well. Let's say one of the pod dies. So Kubernetes realizes, oh, pod has died. So it will try to fire up the worker 2, a pod on worker 2, or on worker 3, or on worker 1. And we'll get into the scheduling algorithm. But essentially, the pod works similarly. So you have worker 1, worker 2. There are 2 pods running on each worker. Well, 2 pods running total in the cluster. And you say, kubectl scale the number of replicas to 3. This RC, Couchbase RC is a replication controller name. And it fires up a pod on a new worker. Then it fires up either that, or it fires up a pod on a same worker, or completely worker 1. And again, we'll get into the scheduling algorithm in a second. But essentially, you give a command. It's a declarative command, and it automatically scales the number of pods within your replication controller. All right, so how does my Kubernetes scheduling algorithm work? Well, it's a 3-step process, essentially. So remember, in the master, there is a scheduler control. There is a scheduler. The scheduler is the one that kicks in and figures out, because the request eventually comes to master, and the master says, okay, I need to schedule this pod. So it talks to the scheduler component, and scheduler component goes through all this algorithm. So it says, I'm going to filter all the nodes that meets the requirements of the pod. Pod may have asked for certain memory, certain CPU, certain namespace, certain requirements pod has given. Now, if a certain host, like let's say you have 4 workers, let's say a worker is already running max number of pods and it cannot run any more pod, so that pod will be rejected from that list. So in that sense, the first step is to filter all the nodes which are going to meet the requirements where the pod can actually run. Memory, CPU, number of pods. There could be multiple requirements, multiple steps that it has to go through to filter all the nodes. Then after filtering all the nodes, then it rank all the nodes. Okay, out of 10, I've brought it down to 4 where the pod can be run. Now I'm going to rank the nodes. And then when it's ranking the node, it looks at things like, okay, I'm going to spread the nodes across regions or across zones, or, well, not regions, across zones only, because the Kubernetes cluster can be across regions, can be across zones. It also favors least loaded nodes. So it has an algorithm by which it starts ranking the node. And once it has ranked the node, then it picks a node. Let's say if there is only one remaining, that's a simple task. It just picks up the top ranked node and schedules the pod over there. And if it is not the top ranked node, then multiple are there. It just picks a random node that, okay, all of those nodes are looking good, and I'm going to schedule a pod over there. So that's how sort of your Kubernetes scheduling algorithm kicks in. But for you, it's completely transparent. You don't need to worry about it. Kubernetes cluster, or Kubernetes master rather, takes care of it. We looked at replication controller. Replica set is sort of the next generation of replication controller. That's what this is targeted to. The main difference is the selector requirement can be far more complicated, or rather far more sophisticated in this case. The selector requirement can have key, operator, and value. Those are sort of the 3 expressions it can take. And the operators are in, not in, exists, and does not exist. Let's take a look at an example to make it more clear. Now, these replica sets are generally created with deployment because it's a newer concept, so it's more applicable to the newer artifacts or the resources that are generated by Kubernetes. Okay, and replica set are the ones that enables horizontal pod autoscaling. We'll take a look at that sample as well. So here is my replica set configuration file. Line number 1, instead of saying v1, which is the case for replication controller, in this case, the API version is extension/v1 beta 1. So it's not a final construct yet, and that's sort of the indication over here. Now on line 10, 11, and 12, I'm saying what are the match expressions. So I'm saying first is key is tier, then operator, which is operator value is in, and then I'm giving a bunch of values. Line 12 says there's a key, there's operator, there's a value. So those are sort of your 3 tuples, so to say, and in the 3 tuple you have 3 key values. The first key being key, second key being operator, third key being values. Now, we have given a match expression. How is it going to match which pod is going to be part of the replica set or not? Look at line 15, 16, 17, and 18. And there I have given random labels. Now, so those are the labels essentially when the replica set is creating is what it's looking at. So you can see it's a little bit more sophisticated, a little bit more granular, a little better control over which pods go into which replica set, as opposed to say just, I'm going to match the label and I'm good with it. So it's a little bit more refined concept, but still extensions v1 beta 1. Services. As we talked about it, services abstracts a set of pods as a single IP and a single port. So it's a referenceable name that your app can access to. It provides simple TCP UDP load balancing. It uses environment variables in other pods. Either that one way is where you can access it, or DNS resolution, where you can give it a service name, and a DNS name resolver is running within Kubernetes by which the name can be resolved very easily. And as we said, it's a stable endpoint for pods to reference. Okay, and the biggest advantage over here is essentially you have a service, and a bunch of pods belong to the service. So from the application perspective, you can still refer to the service by a logical name, but the list of pods underlying the service can change dynamically. That's sort of the beauty here. Let's take a look. Now, on the left side, what I'm showing you, well, first of all, this is one configuration file. Line number 13, particularly, if you see, is how you will split up 2 resources in a configuration file with a divider. And in this case, I have a service, which is on line 2, and a replication controller, which is on line 15. So those are the 2 resources in one configuration file. In this service, essentially, I'm saying line 6 and 7, I'm saying selector is this particular label. And then on line 25, which is part of the replication controller, I'm saying these are the labels that are assigned to this replication controller. So if you step back, you think about it, you will never create a pod by itself. you will always have a pod replicated in a replication controller or a replica set. And so that's how that gives you the ability to scale your pods. And then those are front-ended by a service, which is a referenceable name. You may not need it all the time, but when you need it, that's how you will use it. And this basically shows the connection between the two. So now I'm a Java developer. I need a Java application deployed in Wildfly or a Spring Boot application running as a Tomcat. So I could have that application running in Wildfly that can then talk to a Couchbase service, which Couchbase service is then talking to a pod running in the host or running in the container. Okay. I could have service and replication controller work with each other. So I could have a front-end replica set or a replication controller. Similarly, a back-end replication controller or a replica set. Each of those can then scale independently, but each pod in the front-end replica set would talk to the Couchbase service, which would then talk to the back-end replication controller. So any combination that you want to do is this is how typically you will deploy your application if you are a Java developer. Now, I'm using Couchbase as an example, but it basically means any relational, non-relational, NoSQL database. I think I'm going to skip this part, this particular slide. Let's look at this one here. Deployment. Now, we touched briefly upon this. Deployment is
Arun, sorry to you've just gone off screen share.
Oh. Yeah. Okay. Let's try to share the screen again. Is that better?
That's perfect. Thank you.
Okay, perfect. Yeah, I think I'm going to skip deployment as well because it can get into more details. But let's talk about CRUDing our Kubernetes resources. Let's keep it focused on the Java developer. I'm a Java developer. I build my applications using Maven, Gradle, whatever comes to my fancy, whatever build tool you want to use. I'm going to use Maven, but this can be easily done using Gradle as well. Using Maven, I do my build archive. I say Maven package, or Maven install. Those are the commands that I'm familiar with. Cool, you can do that. Now, if you want to build a Docker image from your archive, then there are a bunch of Docker Maven plugins, but I would recommend Fabricate Maven plugin because that Fabricate Maven plugin is very awesome and it has a lot of features, very actively maintained by Red Hat. So if I'm looking at something open source, no other company better than Red Hat to look at essentially. So the fact that it is endorsed by Red Hat, maintained by Red Hat, I have a very high degree of confidence over there. There are others. I've not played with them, but this is the one I've played with. It's really cool. But essentially, in your POM XML, you will integrate Fabricate Maven plugin. And by Fabricate Maven plugin, you can just say, hey, by the way, you created an archive for me, a jar file or a WAR file. And from that jar file, create a Docker image for me as well. Very simple. Okay, you can do the binding of the goal and the faces. You just say Maven package, it automatically builds a Docker image for you. So really cool. Using Fabricate plugin, you can also push to Docker Hub or any registry that you care about. So that functionality is there. Now, this is a Kubernetes Kubernetes session. So Fabricate plugin also allows you to create Kubernetes resources. So that is super cool, actually. I think that is the most appealing part of Fabricate Maven plugin. One plugin to create your Docker image, push to Docker Hub, and create your Kubernetes resource description. And then it gets better because you can fire up a Kubernetes cluster, and then using Kubernetes Fabricate Maven plugin, you can say, go apply those resources into the Kubernetes cluster. So within Maven itself, you can do all sorts of functionality. Now, I have played with Gradle Docker plugin, but I'm not sure Gradle Docker plugin provides all the Kubernetes functionality. I may be wrong on that, but I've not played with it recently. So let's talk about rolling updates a little bit. Now, what is the concept of a rolling update? I have an application service. This is backend by a replica set with 5 pods in it. By rolling update, I mean one by one, I'm going to update all of them from version 1 to version 2. That's what we mean by rolling update. Okay, and of course, not dropping in-flight sessions, all those things. So rolling updates work a couple of ways in Kubernetes. You can give a simple command. So you can just say kubectl rolling update. So pretty intuitive command name. You give it a replication controller name, and then you give it a new replication controller JSON file. That's it. So you say what this existing replication controller will be updated by this new replication controller now. Or most of the time, you don't want to change any of the attributes of the replication controller, just the image. Well, you can do that too. So in this case, I'm saying rolling update web app application controller, just change the image to Arun Gupta /wildfly app:2. Just change the image to version 2. That's it. A whole bunch of things happen in the background. This is just a log from what happens. Let's look at it graphically. So essentially, when I started my app, I had a web app replication controller. Now, Wildfly 1, the application that is deployed in Wildfly, they're all running on version 1. Okay, all of their labels, the pod labels, are registered in etcd, and that's how my application service works. When I give the command kubectl rolling update, it fires up another replication controller with the new version. And the fact that they are all using, because I'm just updating the image name or the image version, so each of these pods are registered into etcd as well. So there's a very tiny moment where your application service will be guiding some traffic to version 1 and some traffic to version 2, but then very quickly Kubernetes cluster deletes all the pods which were version 1 as part of rolling update command, removes the web app replication controller, and renames web app rc-xx to web app rc. So that's how your rolling update works. And once again, if you look at the bottom of the screen, there is the complete script, the image names, etc., or the commands, etc., are explained over there on the GitHub repository. We talked briefly about horizontal pod autoscaling. That works pretty decently as well. As we said, you can use replication controller and replica set to manually scale the number of parts. So you can say scale -- replicas equal 3, which is cool, but that's boring. How many times? How do you judge when do you need to scale, when do you not to scale up or scale down? Well, that's where horizontal pod autoscaler comes in. It automatically scales up and down based upon observed CPU utilization. And there are also certain application provided metrics that it can rely upon, which is still, I think, in beta, as I understand, as of 1.4.5. But essentially, you have a bunch of pods. You have your application controller, replica set deployment. That's how they're created. And then you have a horizontal pod autoscaler, which is pointing to that artifact, which will automatically scale. Let's take a look at the configuration file. So I can say kubectl autoscale. I can give it the deployment RC or RS. RC and RS are short names for replication controller and replica set. Then I can say minimum number of pods. I can say maximum number of pods. And then I can give how much % utilization of that should happen for the pods before it scales up. Now, how is the % utilization calculated? Is it across all the pods? Is it one pod? Is it multiple pods? All of that is very well explained in the horizontal pod autoscaling documentation. So I would recommend taking a look at that. A simple command in this case, well, by default, CPU utilization is, or CPU % utilization is 80%. A simple command is kubectl autoscale deployment database, which is Couchbase, for example, we have deployed over there. I can say minimum number of pods and maximum number of pods over there. Here I'm autoscaling a replication controller. I don't care what the minimum is. I think minimum is 1 by default. Then I'm saying maximum 5 and CPU utilization of 80%. Okay, so just simple commands over there. How does my configuration file look like? Well, that was command line driven. This is more configuration file driven. And here, line number 2 says, well, first of all, API version is autoscaling /v1. So this is in a different namespace altogether. Second, line 2 says horizontal pod autoscaler. Line 5 to 8 says this is targeting a replica set, and it's giving the name of the replica set as well. And then I'm saying how many minimum number of replicas, maximum number of replicas, and the same command, which is CPU utilization. So you can say, well, just create this resource, and it'll automatically scale your replica set up and down. So this is very handy if you're building your application where the demands can grow up and down based upon your CPU utilization. So far, everything we have talked about, well, most of the things we talked about is all about stateless microservices or stateless containers. Couchbase, of course, is a stateful containers. So if a container dies, if a pod dies, and if a pod is fired up on a different container, if a different host, how is the state managed essentially? So that's where the concept of volume comes in. Now, volume is a directory which is accessible to the containers in a pod. So if a pod dies, then the volume can still persist beyond the container lifescale. So if a pod dies, sure, the volume still exists. A new pod can come up and it can mount to that new volume. And that's what makes a stateful container. There are lots of ways by which these volumes can be mounted and stateful containers can be created. We'll talk about a couple of them today. Common types are you can use host path. So you can say, oh, by the way, I'm firing up a pod and all I'm doing is mounting a volume on the same host. Well, then again, that makes host as a single point of failure. You can mount on an NFS, or of course, you can mount it on EBS or GCE persistent disk. So in this case, I'm creating a pod. Line number 2 indicates that. Line 3 to 6 is the metadata. Line 6, 7, well, 7, 8, 9, 10, 11, 12 are all standard stuff where I'm saying it's just a specification of the pod. Line 13 is where I'm saying, okay, this is where my volume is going to be mounted. I know whenever my Couchbase container fires up, it always writes into war Couchbase lib directory. All I'm doing is mounting that to Couchbase data, defining a new volume over there. And the volume is further defined on line 16, 17, 18, and 19. In this case, I'm just using a simple host path, but this could have been easily done as an EBS store or whatever you care about. So that's what allows your pod to be stateful. And if a pod dies, comes up on another one, let's say if it comes up on the same host, then you can still mount to it. And there are ways by which you can create stickiness of a pod to the host. So we'll not talk about that here, though. Let's take a look at it, a more realistic example where host is not a single point of failure. So in this case, it's a little complex image, but essentially it's got one master, 2 worker. I got a Couchbase Docker container running with the replication controller or replica set, and I have exposed the service publicly so that I can access the Couchbase web console in this case. Now, if I do the host NFS path or the host path, then my storage is on the host. That's okay, because if my pod comes up on the same host, then I'm golden. But that's not how I scale my service, though. So what I'll do is I will move the volume to EBS. Now, if a pod dies, wherever it comes up along, I don't care really. If it comes up on a different host, the volume is mounted for me on that particular host. So because it's being on Amazon, it gives you that flexibility. So there are, well, that concept in Kubernetes is called as persistent volumes. And the way this works is, well, you first provision a network storage. Network storage could be ABS, persistent disk, whatever, all sorts of different provision providers are there. Then you request a storage. Okay, the provision network storage is on EBS. Then you say, okay, I want a claim. Out of the 10 gigabyte of memory that you have provisioned over there, I'm going to make a claim of 2 gigabyte, and then I'm going to use that claim as my volume. So it's a 3-step process here, essentially. And again, the details for all of that are explained in my blog at the bottom, which explains how do you create an EBS volume, how do you create a PVC, and how do you use that claim. And there are resource configuration files for each of those. Talking a little bit more about how do you create a cluster for databases on Kubernetes. This is typically one of the most asked questions by our customers. How do we fire up a Couchbase cluster? And I've been working with a lot of customers recently who are taking Couchbase into different container frameworks. Kubernetes is definitely one of the popular ones. And so the way we came up with it, well, first of all, Couchbase as a database it's a very homogeneous architecture. Each node in the Couchbase cluster has exactly the same set of features. There is no master or worker. If you have a master worker architecture, master is sort of where you write, worker is where, or the slave is where you read from, it becomes choked. That's a fundamentally flawed architecture. It has worked, but you have to work around it with a lot of sharding and stuff like that. Couchbase, on the other hand, is a very homogeneous architecture. But in order to automate this, we have a master replication controller and a worker replication controller. And master replication controller is also a service, because that's a uniquely identifiable name that other workers can correlate to. So we fire up a master replication controller with one replica. That's my Couchbase service. Any node that comes up then talks to that service and adds itself to the cluster, and that sort of makes my broader Couchbase cluster essentially. A new concept introduced in Kubernetes 1.3 is pet set. And pet set really allows you to build stateful containers, as a matter of fact. So stateful pods, actually. Each pet set has 0 to n-1 pods. So essentially, your pet set has n pets. The labeling goes from 0 to n-1. Each pet set has a deterministic name. So in the previous case, for example, you saw how we were creating a master so that we can get a unique name where other nodes can be added to the cluster. In this case, we don't need to, because I know when I'm creating a pet set, it's by default going to have a deterministic name, and it has got a unique identity. So if my pet set is named as Couchbase, each pet set or each pet in the pet set would be named as Couchbase -0, -1, -2, so on and so forth. So I know the exact name and the number of the node, and that makes it a lot more easier for me to create my cluster. And it's only for cluster creation. After that, it's a completely homogeneous cluster. You can read and write from any node. Talk a little bit about multi-tenancy, actually. So Kubernetes has this concept of namespaces. Namespaces allow to partition resources into a logical group. This way, each namespace could be given sort of predefined number of memory, CPU units, number of replication controllers, etc. can be fired up. So if you have a much bigger Kubernetes cluster with vast amount of resources, then you can create namespaces where multiple teams can then deploy application within that namespace. Well, each namespace essentially provides scope for resources to avoid collisions. So I could have a same replication controller, same name of the replication controller across two namespaces, but not within a namespace. You can have policies, basically start assigning, you have the right authentication and the authorization to deploy and create resources in a namespace. And of course, constraints, which says how many pods can be created, how many replication controllers can be created. So namespace truly enables multi-tenancy in Kubernetes in that sense. Anti-pattern, though, is if you have slightly different resources, or, for example, different version, those should not be deployed on namespaces. Namespaces is truly multi-tenancy. If it's a different version, just use a different version, different metadata of the configuration file, as opposed to deploying them on a different namespace. So it's an important part to understand that anti-pattern for namespaces, essentially. Use labels is basically the recommendation if you have slightly different resources. Another new concept in Kubernetes, I think it was introduced in 1.4 or maybe 1.3, is a run once jobs. Certain times a pod is you may want it to keep running all the time if it's an Nginx pod or a Couchbase pod or a Wildfly pod. But certain times you just want to do the job once. That's it. I just want to invoke the application once and be done with it. That's called as a batch job. Now, RC, RS deployments are not suitable for that. But there are three types of batch jobs. One is non-parallel, where only one pod is started. You could have a parallel. Within parallel, you can say, I want to start 4 jobs in parallel, and I want all 4 to complete. Or you can set up a work queue. Work queue is a little bit more elaborate, but let's take a look at it. In this case, again, the API version is batch/v1. It's a new namespace here, and the kind is job. If I look at line 9, that's where my container is specified. And I'm keeping the container purposely dumb simple. All I'm saying is the name is wait. I'm using an Ubuntu image, and I'm just saying sleep 20. So essentially, this container will launch an Ubuntu. This pod will have an Ubuntu container that will sleep for 20 seconds and exit out, and that's it. It cannot be into an RC because the restart policy is set to never. So you cannot wrap this in a replication controller or replica set. This container will do the job once, and that's it. So I think that's very handy. So a typical example is you are running a Couchbase database, and you want to store some JSON data or fetch some information from the Couchbase database as a Spring Boot application, and you want to do it this only once. And if the application fails, you want to make sure that it leads to a successful completion. So that's a run once job, essentially. And that's my example here. So now here, if you think about it, I have a Couchbase pod running as a replication controller with a single replica. The pod has a label, and the label is what makes it accessible as a Couchbase service. And then on the right side, I have a Spring Boot application that's a run once job that just talks to the Couchbase service, which then writes to the database directly because of how the service is configured. Another sophisticated command that is helpful in Kubernetes is health checks. Health checks are performed by kubelet. Yes, there are certain basic health checks that are provided. So if a pod dies as part of RC or RS, it'll automatically be started up again. But you also have probes in Kubernetes. There are liveness probes and readiness probes. And each of these probes could have diagnostics assigned to them. So you could run, for example, a random command from the container, and if that exits with the appropriate status, that means it's successful or not successful. So that's sort of a container exec. Or you can just check that if you can TCP to a particular socket, if the socket is open. Or you can run an HTTP command, for example, and then the HTTP command has to return a certain specific code, and that's what you're expecting. Okay, so let's take a look at that. Now, I'm firing up a deployment. In this deployment, line number 6 says it's one replica. I got some labels, a metadata assigned to it from line 7 to 10. Line 11 to 15 is the spec of the container. Line 17 is where I say, oh, by the way, it's a liveness probe. And all it's saying is Couchbase has a REST API by which you can query anything about Couchbase Couchbase database. So all I'm saying is line 20 says port 8091, and line 19 says just give me /pools URI in the container, and if that returns a 2xx error code or 2xx status code, then I'm golden. And it's going to take 30 seconds to begin with to wait, because that time the Couchbase database is booting up. And then after that, every time it makes a liveness probe, if it times out in more than 1 second, that means the Couchbase container is dead. And essentially what happens is, if the Couchbase container is reported as not live, then Kubernetes cluster will fire it up again. Pretty much the last piece that we're going to talk about today is monitoring Kubernetes resources. So I have a master, a bunch of workers, a bunch of pods running over there. I want to monitor those resources. How would that work? So kubelet, of course, is there. It monitors my pods. If the pods go down and stuff like that, those are restarted again. Depending upon how you are running your Kubernetes cluster, if it's running on Amazon Web Services, then you have Heapster, InfluxDB, and Grafana. Those are add-ons that are installed in Kubernetes cluster. If you're running on Google Cloud, then those are enabled as well as add-ons. If you're running as a Minikube or COPS, then those plugins need to be additionally installed. But the key part being, Heapster essentially is run as a pod, and I'm showing 4 containers in this pod here because that's how it's running on an Amazon, with 4 different containers in a pod. But Heapster basically collects all the different pods. And the way it does it is, well, once it collects the data, it stores it into InfluxDB, which is a time series database, and it uses Grafana as a visualization dashboard. Okay, and how Heapster collects this information? Well, it talks to the master, and it also talks to the kubelet to collect all that data. So that's sort of how you monitor Kubernetes resources, and this is given to you by default. There is nothing fancy you need to do about this. I'm just showing you a snapshot of some of the Grafana dashboards. Fairly easy to set up and get going on this. I recently blogged about this, so take a look at my blog, and there are more details about how do you fire up on this. But if I were to explain this, on top left is what I'm showing is individual CPU, memory, network, and file system usage. On the right, I'm showing same metrics, but for the overall cluster. And then on the bottom, I'm showing same metric, but by different nodes. So you can create all sorts of fancy chart boards. You can, of course, it's Grafana, so you can customize your dashboard based upon the metrics data that are available to you. If you're looking at more professional Kubernetes monitoring, then there are other vendors, commercial vendors, that have a pretty solid offering. I particularly looked at what Sysdig and Weaveworks has to offer for Kubernetes monitoring. I was recently at AWS reInvent, and I was pretty blown away by how deep the Sysdig monitoring can go into, particularly from Kubernetes aspect, and similarly with Weaveworks. So there is some really good work happening with these two vendors. Essentially, I would say take a look at it. And of course, New Relic and Datadog has Kubernetes monitoring as well. All right, so I think that's pretty much the end of it. If you want to understand the basic Docker concepts, I have a free book that is available from O'Reilly. Just scan the QR code and it'll redirect you to the page, which gives you an option to download the free ebook. If you are interested in learning more about Kubernetes, I did an online training for O'Reilly, and it'll guide you to that. Well, you're looking for slides. So yes, slides are all available. It's a very transparent, open source way. GitHub.com, Arun-Gupta/Kubernetes Java sample. All the slides are available over there. Kubernetes.io is typically where I go for all my documents. It's a very kick-ass job on how they have done the documentation. Always can be improved, but it's pretty good one. Couchbase can be run on a variety of container frameworks, whether it's Docker Swarm mode, whether it's Kubernetes, whether it's DCOS. All those recipes are listed on this URL as well. And with that, that is my last slide.
Awesome. Another wealth of presentation with a wealth of knowledge. Thank you very much, Arun. That was awesome. So we've got some questions. One question from Perez Pardo JC, asking about the relationship between an external load balancer in the Kubernetes cluster and other services as well. So if you have some nodes, a couple of production environments with a front end and a database, and you want to expose it externally, will you need like 2 load balancers, 2 DNS redirections, and also something internally, or do you miss something out?
Yeah, so when you're exposing your service, now we didn't cover, I mean, this is a 1-hour presentation. We could have talked a lot more about service itself. But essentially, when you are firing up a service, you can set up the type of the service on how it needs to be exposed. You can set up the type as load balancer. And the moment you set up the type as load balancer, if you're running on Amazon, it'll automatically fire up an ELB instance for you. And that ELB instance is intelligent to figure out how to load balance your pods running as part of that service. So if you're running on a cloud provider, ELB or whatever the right load balancer for your cloud is, it'll automatically be provisioned for you.
Okay. Another question from Alvarez. Is Docker Swarm mature enough to be used in a production environment? And I guess which would you prefer, Docker Swarm or Kubernetes?
Well, Docker Swarm and Kubernetes, it's a same question like, do you use VI or Emacs? Do you use Java EE or Spring? Do you prefer Windows or Mac? Don't try to take a hammer and try to hit a nail. Figure out where your nail is, what's going to solve the problem, and use the right tool for it. In short, I think Docker Swarm by itself is being used in production by a lot of customers. Particularly, take a look at Docker Data Center, which provides a full-blown production environment. So everything I talked about today, in terms of services, in terms of pods, scheduling across hosts, monitoring, all of those capabilities are available as part of Docker Universal Control Plane, absolutely. So take a look at that, and I think you'll be surprised.
And what kind of nail would you hit? Would you use what kind of nail would you use Docker Swarm on over?
Yeah, so typically, the reason I've seen people using Docker Swarm is the seamless integration. Kubernetes is an opinionated framework. So the learning curve, the first time when I started reading about pod and services and configuration files, my head started hurting a little bit. But with Docker Swarm, it's a very seamless integration on how Docker Compose and everything works. And the fact that it's coming from the same vendor is a lot easier for me to get that seamless integration as opposed to Kubernetes, who also wants to work with RKT, which I have not seen anybody using.
Okay. Question from Marin. What's your opinion, and this may be the same answer, I don't know. What's your opinion, is Amazon ECS with a which is semi-managed service, or Kubernetes?
Yeah, I have played with ECS, and I have played around with it. The ECS container, well, one of the value proposition of Amazon in general is the SaaS model, and I love that part. So it allows me to get fired up rather quickly. I want this, I'm going to figure it out. If you're okay to live with the finickiness or the whimsical behavior of ECS, absolutely go for it, because everything is managed for you. And I would particularly say, take a look at some of the announcements that were made at AWS reInvent last week. On when you're looking at a container orchestration solution, don't look at it only as a container orchestration. You are looking at it as a broader part of a solution. I want to do a CI/CD. I want to make sure my tools are in line. And Amazon has a rich ecosystem of tools now that will complement ECS very well. Kubernetes ecosystem is definitely growing as well.
One question about, one person in the IRC was probably a lot of it was over their head, and they're asking where can they find the kind of basic concepts about Kubernetes, or I guess Docker as well to some extent.
Well, the Docker concepts, I think the book, mini book that I wrote, that does explain a lot of the basic Docker concepts. And as I said, I have this Kubernetes for Java developers book. It should be getting released sometime next month as well. So that would be a good one. Or if you cannot wait and you're ready for Christmas break, go to kubernetes.io and start reading over there.
Yeah, that's someone actually linked that as well as a Kubernetes basics page in there, which looks.
Yeah, I think Kubernetes has done a very good job of Kubernetes 101, 201, and they kind of break it down by that series. That is very helpful.
Okay, people are asking if you can show the link for the book of Docker again, or the QR code, so that people can grab that.
Yeah.
And while you're grabbing that, Christo Porna is asking, is there any tooling for provisioning, since it can use Docker, and could you use Docker machine with drivers?
That's an orthogonal question that's not related to Kubernetes, first of all. So the way I would say this is, yes, you can use Docker machine with drivers, but you cannot set up your Kubernetes cluster using that, though. If you're setting up Docker machine with drivers, yes, you can use drivers on Amazon, Google Cloud, whatever cloud provider you use. But then you are basically taking, which is perfectly fine, consciously taking the route of Docker Swarm, essentially.
Okay. Actually, there's another question here I actually missed from Stritzy. Is there any possibility to get notified when an instance dies and a new one is created?
Yeah, absolutely. kubectl actually has this events API. So you can subscribe to that events API, or you can look at kubectl events, and it will show you how the events have happened. And those events basically say the pod has died and the new pod is being restarted. Take a look at those monitoring tools that I was talking about. You can get really fancy with those tools in that sense.
Okay. And products like the ones from CoreOS, Tectonic, Redshift, is this just adding an extra layer with more features, or is there anything that can make it easier to administrate?
So my belief, I mean, I have not played a lot with Tectonic or Redshift at all, as a matter of fact. But my belief typically is, if I'm using, let's say I've logged into Kubernetes or Docker Swarm, I am always looking for capabilities within the framework first. And if something is not available in the framework, then I take a look at it. One of the beautiful frameworks that you want to look at is, for example, Red Hat OpenShift, if you're looking at Kubernetes seriously. Because OpenShift, in that sense, really provides a wonderful CIs. It builds on top of Kubernetes, where you are a Java developer. I don't know how to take this Java app and convert it into a Kubernetes resource file and automatically do CI/CD. So Kubernetes builds OpenShift builds that entire pipeline for you seamlessly that works very well out of the box.
Okay, awesome. One last question before we go, because we're 5 minutes over already, but this has been very good Q&A. So Jan T. Kim is curious as to what to put in these Wildfly pods. So asking, is there a book or resource regarding what to actually develop on Wildfly? So what applications and how to build them and that kind of thing, based on Docker and Kubernetes?
Yeah, absolutely. I mean, the link, well, if we go here in the references section, the slides are here. So if you look at, say, well, let's go here. So I'm going to go here, go to page. So if I go here, in Kubernetes Java sample, This is actually a full-blown workshop, as a matter of fact. If you take a look at it, it says how do you create resources, how do you use configuration file, how do you use a replication controller, how do you use service, a full Maven example, a rolling update example, all sorts of examples are there, and all the configuration files are there as well. Update one now. So here it talks about how these images are pushed out, and then you can take a look at what that image description looks like, and then it kind of shows exactly what you need to do. So I would say that's how I have picked up technology. If you look at this URL, lots of configuration file, lots of workshops material over there.
Awesome. And so what I've also done actually is I've popped into IRC your GitHub profile, and the repository you're using then is the Kubernetes Java sample. But there's a whole bunch of other stuff actually. If you're interested in Wildfly or Docker or images or microservices, a whole bunch of stuff in there as well. So I mean that leaves just me to say thank you very, very much, Arun, for another amazing presentation. In fact, the number of sessions that you've given us on the VJug is really, really good. So thank you very, very much for all your support. And who knows, probably see you on the VJug scene again, eh?
Who knows? Thank you for having me. It was a pleasure.
Awesome. Thanks very much, Arun, and thank you everyone for watching. The next session is going to be in just a week's time, and Arun actually mentioned Gradle a couple of times. And if I was to go to the meetup.com/virtualjug, it'll tell me that their next session is on December 14th, which is extremely fast builds with Gradle, and the speaker is Cedric Champeau. Yeah, Cedric Champeau. So Cedric is massive on Gradle, and is one of the core committers for Gradle. So a must watch session for any Gradle wannabes or Gradle developers out there using that build tool. So thank you very much, Arun, and I'm sure I'll see you soon.
Bye-bye.
Bye.